Let's look at how to calculate the pH of a strong acid. So, first of all, you have to remember that when you have this H plus here, or HCl, okay, HCl, when you put it in water, so HCl in water, it's going to dissociate completely into H plus ions and chloride ions. Another way to write it would be HCl plus H2O is going to give you H3O plus Cl minus. Now H3O and H plus are the same thing. This top way is just a way to write it without showing the water, okay? But whenever you have this, 100% of the HCl changes into H3O ions, okay? So if you have a 2.5 molar solution of HCl, that means you're going to have 2.5 molar of H3O. Alright? Because 100% of it dissociates. Okay? That's going to be different, you're going to see in a later video, when you have a weak acid that doesn't dissociate completely. Alright? So then you need to remember that pH is equal to the negative log of the H plus. Alright, well, we know that our H plus is 2.5 molar. Alright, and so a lot of times you'll see brackets around this, okay, because that stands for the concentration of the H plus. So the pH, if you plug the numbers in, equals a negative log, and then you put in 2.5 molar, okay, and then you'll get pH equals, so if you do the math here, you end up with a negative 0.39 or something like that. So a negative 0.39. And yes, you can get a negative pH. Alright? Okay, now let's look at a different problem. Okay, so what is the pH of a 3 molar solution of sodium hydroxide? Well, the first thing that you got to do is you have to write the dissociation. So NaOH, when you put it in water, it's going to dissociate into sodium ions and hydroxide ions. Now, sodium hydroxide is a strong base, and so you have 3 molar of this, and so for every 1 mole of this, you're going to get 1 mole of that, okay? And so for every 3 moles of NaOH, you're going to get 3 moles of this OH minus, okay? So this would also be 3 molar over here. So you would have this formula here is that the POH is equal to the negative log of the OH minus. And so you could solve that. So you could go POH equals a negative log of whatever this hydroxide ion concentration is. And I was going to put that in there. So I was going to substitute in 3 molar right here. And so if I do that, so if I go negative log and I put in my 3 molar, alright, I get this. I get that my POH, that's not what I wanted, that my POH, back to the pen here, that my POH is equal to a negative 0.48. Alright? Then you got to remember this formula because we want to get pH. That pH plus POH equals 14. So if we take 14 to solve for pH, so we'd get pH equals 14 minus the POH. Okay, so I just moved the POH over there. So if I take 14 minus a negative 0.48, I get that my pH is equal to 14.48. So that would be very, very basic. Alright? Right, and notice again that pH, we might say that the pH scale goes from 0 to 14. Well, that's in general, but actually it can be greater than 14. Alright? So let's try another problem here. Okay, so what is the pH of a 1.5 molar solution of sulfuric acid? Okay, now sulfuric acid is H2SO4. So when it dissociates, it's going to dissociate into H plus, okay, plus HSO4 minus. Alright, and so for every 1.5 mole of this, you're going to get a 1.5 molar solution of H plus. Alright, so then you would just go the pH equals a negative log of the H plus. So pH equals a negative log of 1.5 molar, because H2SO4 is a strong acid. So your pH would then equal negative log of 1.5. So that equals a negative 0.18. Okay, now here's a little bit different type of a problem. So we have barium hydroxide. So we have barium hydroxide, and it is 1.5 molar. Okay, when you put barium hydroxide in water, okay, it's going to dissociate into barium plus 2 hydroxides. Okay, now what's kind of important about this is for every 1.5 molar of barium hydroxide, so for every 1.5 moles that decomposes, you're going to get 2 moles of hydroxide. So you have to double the molarity here. So to figure out the pH, you're going to go first have to do the pOH. So the pOH equals a negative log of the OH, negative. Alright, so the pOH is going to equal a negative log, and you got to put in the 3 molar. Alright, so the pOH equals negative log of 3. So it's going to equal 0.48. Okay, that's what the pOH equals. And then remember that the pH plus the pOH equals 14. Alright, so then to get the pH, you would have to take 14 minus, plus there, which it ends up being a plus, but 14 minus, and this should have been a negative here, a negative 0.48. So really, when you have two minuses, you're adding them together. So the pH is going to equal 14.48 molar. Now let's review just a little bit. When you have a base that's not a 1-to-1 mole ratio with the barium, like hydroxide, see how it's 1 to 2, and that dissociates, for every 1 mole of your original base that dissociates, here we're getting 2 moles of hydroxide. So you have to make sure that you take into account that if that dissociates completely, which a strong base would, you have to make sure you double the molarity. Now if you look back at the other one that we didn't have to do that, because for every 1 hydroxide here, we got 1 hydroxide here. So if this was 3 molar, this is 3 molar. Okay, but when you have a hydroxide that isn't in a 1-to-1 ratio, you have to make sure you take that into account.